Hi, John Valvano here. In this video, we're going to talk about functions. Now, there are three aspects of a function. The first is its prototype or declaration. I don't care what you call it, but you got to do it, okay? And in the prototype or declaration, it doesn't tell us how it works, but what it does. So I'm going to take this square root algorithm we developed in the last video and convert it to a function to make it more useful. Okay, and in the prototype, we are going to give the parameters of the function. So the function is going to have a return value of an unsigned integer. Okay. The second thing we got to define is the name of the function. I don't know. I like names that are self-evident. So I'm going to call it square root because that's what it does. And then the third thing we do in the declaration is define the input parameters. Okay, so we have the input parameters, we have the output parameter, and we have the name. Okay, and if this were more detailed, I put a bunch of comments in there. But for now, this is the necessary information we need to have a prototype or declaration of the function. The second thing we're going to do is invoke it. Okay, and to invoke a function, we're going to give it some parameters and call it. Okay, now if you notice, I haven't implemented it yet because that's what I'm thinking. I have in my mind what it does, and before I implement it, I have in my mind how I'm going to test it. Okay, and so I need some test parameters. Okay, I'm going to call it input and output. Okay, those are going to be some test parameters, and I'm going to test it. Okay, so somewhere down here, I'm going to invoke the function. Square root of n. Okay. All right. Oops. Put the thing over here. Okay. So this is the invocation right here. This thing invokes the function. All right. I'll put some more stuff in here later, but now the next thing I want to do is implement it. And so, being lazy as I am, and to make sure it exactly matches, I'm going to copy the declaration. And so down here, the third thing we're going to do is implement or define the function. Okay? All right. And you notice up there was a semicolon, and down here there is a brace. Okay? And I'm just going to, copy this stuff here, remove it from there, paste it there, make it look pretty. Oops. It's the same algorithm. Basically, I start at 0 and I search until I find it. Okay, and then I'm going to return the answer, y. Okay, so this is the program, the function definition, okay, which has the same name and the same parameters as the declaration. One last thing, how do we test it? Let's put this in a for loop. N equals 0. In less than, I don't know, 100, less than or equal to 100, in equals in plus 10. Okay, so we'll try it with a 0, 10, 20, 30, 40, 50, etc. Okay, now open the brace and close the brace. All right, so this is going to be my test routine, which I'm going to use to see if my function works. All right, again, I got my board plugged in, and so the next thing I want to do is build it. Okay, see if I got any errors. I do. That happens all the time. What did I do wrong? Yeah, but okay, we'll just ask it. What did I do wrong? Okay, so I. Okay, well, sheesh. I call it in here and I call it I there. Okay, better. Oops, spell it right. All right, we're good. All right, let's try it again. Build. Yeah, much better. So build, debug. Okay, we're in the debugger. I placed a breakpoint here at the output. And so what my workflow is, I'm going to run to that spot and then do a step over. Okay, so the square root of 0 is a 1. Run, step over, run, step over, run, step over, run, step over, run, step over. You can see my square root is not very good, but nevertheless, it is what it is. Run, step over. And so up in this window here, I have a sequence of 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and to test my algorithm. All right, that's my function. The function, you remember, has 3 parts to it. The first is the prototype or declaration. The declaration has the name, the input parameters, the input parameter types, the function return value, and the function return type. It has an invocation, which is where we pass it an input. We execute the function, it returns the result, and we can store the result wherever we wish. That's the invocation. And then the third is the definition, where we just take our algorithm, process the input information, calculate something for our output, and return that value to our function. All right, have fun.